Okay. Well, thank you everyone again. It's great to be with you this morning, and I appreciate your time. My name is Jared, as was mentioned, and I'm excited to be here with you and hopefully share some things about some of our switches. I like to do this as casual as possible, so please feel free to ask questions at any time. If you have a question, you can either type it in the chat or you're welcome to unmute your microphone and ask the question that way as well, whatever you're most comfortable with. Even if I'm in the middle of talking and in the middle of a slide, I am okay to be interrupted. That's no problem for me. So I want to make sure we get all your questions answered. As Vicki mentioned, we have a lot of topics to go through today. We are going to go through some of the switches themselves and introduce you to those and highlight some of our most recent new models so that you have an idea of what their capabilities are. And then we're going to go through several different technologies that are basically used for video and audio over IP. And every one of these topics can be its own individual, very long conversation. In fact, we have done webinars on each one of these topics individually that are each an hour long. And so my goal today is to try and give an overview of what each one of these technologies are, so that when you are in a switch configuring it for whatever it is, whether it's multicasting or QoS for Dante or QSys or anything like that, you have an idea as to why you're clicking that button. And then at the end, of course, I will direct you to where you can go to get specific instructions for lots of different brands of equipment. And those specific instructions will tell you exactly how to set the switch up for that brand that you're plugging into it. So that's kind of my goal today. So to start off with, why is it that we are talking about VLANs and multicasting and QoS? Well, as you can see, in our audio video industry, these are very commonly used for video over IP or audio over IP, and in some cases for control of the entire network and of the entire system. And so if we understand what each one of those technologies does, we can understand why they're being used for things like, Just Add Power or Crestron NVX or Dante, things like that. So that's kind of the goal today. Okay. As far as an introduction to the switches, we do make a lot of switches, and there's a couple of slides here if you were on our previous webinar last month that may be familiar, but I promise there's only a couple that may be the same. Everything else about this presentation is different. I put this slide up to show you that we make a lot of switches. Everything from what you see on the left there, from a very small 5-port switch all the way up to very large 48-port switches, and of course all sizes in the middle. The idea is that you have the opportunity to use a switch for whatever the use might be, whether it's a main switch in your rack of equipment that you need a lot of ports for, or a very small switch maybe behind a display or in a small cabinet where a couple of things are going to be plugged in. Either way, we have options and solutions for that. Many people ask, what is the difference between managed and unmanaged and AV series versus security series, or are AMS versus XMS? And really all it is the location of the ports. The AV series, or what we call the AV series, just means that the ports are on the back side. So when you put them in a rack, you have a nice clean looking front face with no ports, because they're all in the back where the rest of your audio video component connections are. The security series, or XMS series, is just simply ports on the front. The switches have the same capabilities. and they also can be used for either thing. Just because it's a security series switch does not mean that you can't plug audio video components into it. You can. The switch does not care what type of product is plugged into it. All it's going to do is pass data. So it really comes down to what is your preference for that installation. Do you need or prefer ports in the front or ports in the back? And that really is the main difference between them. Okay, a couple of new switches that we have are called the SW series, which are a new series, obviously not AMS or XMS, but they stand for switch. I know we're being really inventive and with that and creative with that, but that's what it is. So we're going to move away from AMS and XMS as time goes on and move to SW, which just stands for switch. And the reason that we're doing that is so that we can avoid confusion of, well, which one do I choose? Is it a video switch or an audio video switch, or is it a security switch? Because none of that really matters. Switches, like I said, will pass data for any type of device you plug into them, regardless of their name. So a new one we have here is a small 4-port, or technically a 5-port switch. And what's unique about these is they are unmanaged, which means you do not have to configure them at all. There's no user interface to log into. They are plug and play, but as you can see, they do provide PoE+. So the reason we did 5 ports instead of just 4 is so that all 4 can be available to power devices, with the 5th one being the one that plugs back into the network somewhere else so you have connectivity. And this is a great little solution if you have a small space where you need to have a couple of devices, maybe some IP cameras that need to be powered, or a touch screen, or anything that is PoE powered. The next one is the same idea, just more ports. It's an 8-port, but technically a 9-port with that separate uplink port. And it has, of course, being in a larger chassis, can have a larger power supply in it, so it can power more devices. So those are 2 of the new ones that we have that are very small, unmanaged, very simple to use, but provide PoE power when you need it. There is another one that's unique here. We call it the 05PD instead of just regular P, and that stands for Power Device. And this one is different because it does not plug into a regular electrical outlet. It will be powered only via PoE. So you use a PoE switch or an injector to power this switch, which means all you need to it is a category network cable. You do not need power in that location. And then it has a pass-through that will send 15 watts of PoE out to another device. So you can use it, and it does include some different things like rubber feet, magnetic feet, wings, if you need to mount it onto a surface, things like that. So there's lots of accessories that are included for different ways that you can use this one. One of the ways that we've seen a lot of people use this is behind a TV or a display, where you maybe have to also power the video over IP device that it is also behind that display. So PoE power comes in from a network switch or from a PoE plus injector. It can then send power out to another device that needs to be powered behind that display, leaving 3 other ports as regular data ports to plug in maybe a streaming device or the TV itself or an automation system controller, whatever the case is that you need there. So very flexible switch that offers a lot of options in a very small package. I don't know if you can see this, but the switch is really maybe about this big. It's not very big at all, but can do a lot of things. So we're really excited about that particular model. And that's really it for our unmanaged switches that have PoE capabilities. Of course, we also have unmanaged switches that are just standard switches that do not have PoE in them. So you have both choices for whatever your need is. Now I want to move into managed switches, and sometimes people get a little bit afraid of managed switches because that means to them that there's a lot that the switch can do. They have to log into it and configure it. And while that is true, there is no need to be afraid of managed switches because yes, they can do a lot, but you don't have to do anything with them. You can just plug regular devices in and they will work just like a regular switch. They will pass data without any problem. Some of the unique features about our managed switches is they are full speed switches, which means they have the capability of double or more the amount of ports that are on them. So if I have a 24 port switch, I have a backplane speed of at least 48 gigabits or more. What that means to you in the real world is that you can have a gigabit going in and out of each single port at the same time, and the switch is capable of doing that. Essentially, that means you're not going to have data slowdown problems. They are also full layer 2 and layer 3, and I won't get into those differences today. Layer 3 basically means that the switch is very intelligent, it's very smart. They also are, of course, are PoE and PoE Plus capable. They have certain things turned on by default, like spanning tree for our friends that use Sonos products. And then, of course, they have fiber uplink connections, and on a lot of them, especially the SW series, you can combine those fiber uplinks to create larger bandwidth between switches. So if you're running a very large video over IP system, then you don't have to worry about bandwidth between the switches because you can combine those fiber ports if you need to. Of course, with that, we do support virtually every manufacturer of video over IP and audio over IP products if they're Dante based. And just to kind of give you a little example, you can see I've listed a few brands there. I do have a slide later on that shows many more brands that we are partners with and work very well with. So with that, there's 3 switches that are new that I want to highlight. Go ahead. Any questions so far?
Hi, Jerry. We have a guest asked about how about ACL?
AVB?
ACL, possibly access control needs, right? ACL.
Oh, ACL. Yes, the switches they do have an ACL, so you can access control. I'm not going to go over that today, but yes, they can do that. Okay, good question. Anything else?
So far, no. Yeah, please go ahead.
Okay. So 3 switches real quickly to highlight in the SW series. This is our 610 series, which is a 24 port with ports on the back. This is the back side of the unit. And as you can see here, it has 4 fiber ports. Our previous model only had 2. These can be combined for up to 40 gigabit worth of data transfer capability. We do have 2 48 port switches. One is called the 510 series. The other is the 610. They have the same capabilities except for one thing. The 510 series has fiber connections that are 1 gig capable, whereas the 610 has 4 ports that are 10 gig capable. And the reason we do that is because it does cost less to manufacture the 1 gig ports. So if you need a 48 port switch, but you don't need 10 gig fiber ports, then you can save a little bit of money and use the 510 series, and it works really, really well. So we have both options available to you. 2 things to note on all of the managed switches is they do have a scheduler built in, so you can schedule the PoE for an individual port to be on or off at certain times. So if you want to turn something off at a certain time of the day or night and then back on at another time, you can schedule that to be done inside the switch. The other thing is they have what we call a self-healing, which is it will monitor the IP address of the device on that port, and if it loses its connection, it will then automatically power cycle the PoE on that port in an effort to try and reboot that device and bring it back up online. So I realize I did talk about this a little bit in our previous webinar, but I just wanted to mention it again because it is a unique feature to the managed switches. You do not have to use this feature, of course, but it is there if you want to, in an effort to try and save troubleshooting calls for you. And then, of course, we do support the two different types of PoE. There is standard PoE, or sometimes called 802.3 AF, which is 15 watts per port. We also support PoE Plus, which is 802.3 AT, or 30 watts per port. And of course, yes, the switch will auto-negotiate whatever the device asks for. So it will provide either no PoE if there's none requested, or 15 watts or 30 watts, depending upon what the device that you plug in asks for. So it's completely auto-negotiating. You don't have to worry about that. And of course, it will power up devices up to whatever the power budget that is in that switch can provide. Okay. So now I want to get into some of the different technologies that the switches can do. And again, at the end, I will direct you to the place on the Legrand AV website where you can go and get specific information about how to set up a specific brand of equipment. I'm not going to go through all of that today. I just simply do not have time. But I did want to go over a little bit about what each technology is and why it's important and how it works. So with QoS, it stands for Quality of Service. And it's a fancy name for saying I'm going to prioritize one type of traffic over a different type of traffic. And where we really see this used in our industry is for things like Dante audio, where it is time synchronized over the network for long distances and large spaces. And that's really the main place that we see it. I'm not going to go through the whole setup, but I do want to point out that as you can see here, I've listed two screens that are in the switch menu system for QoS. And really, that is it. That is all you have to do is two screens worth to set up QoS for a Dante system. My point is that we talk a lot about technology and what these things are, and we're certainly going to do that with VLANs and with multicasting. But when it comes down to it, it's very simple to set up inside the menu system of our switches. Most of the time, there is one or two screens that you need to know about, and that's about it. It's not very difficult to set up. But again, today I wanted to go over what each one of these technologies is doing so that you know why you're clicking these buttons. With QoS, it runs on a system called, as you can see right here, DSCP-based QoS. And this is what sets up the time synchronization as the highest priority for data traffic, with the audio below that, because if the audio goes first, it may not be synchronized. And so they put the timing on top of that and put that as priority traffic. And that's what you do in these two screens. Very, very simple. As far as VLANs go, I'll get a little bit more into what a VLAN is. It stands for Virtual Local Area Network. That's really all it is. And it is a broadcast subnet that is separated off from every other subnet in the computer network, or in the network. And really what this allows you to do is have multiple subnets or multiple networks using the same network equipment. So instead of having to go out and buy 2 or 3 routers and 2 or 3 different switches and 2 or 3 different access points, you can create virtually different networks using just one router and one switch and one access point if that's what you need. So it really works very well. However, VLANs do create fences or walls between devices and all of the data that flows around. That's the whole point, is to create that separation. Sometimes you can have a gate or what we call a door that can open in one of those VLANs to let some traffic through to a particular device. And we'll go over that here in just a moment. So please be aware, if you aren't already, that sometimes VLANs can be used in a good way, and sometimes they create problems that you wouldn't otherwise have. So my general rule of thumb with VLANs is our switches can do 4,000 VLANs. That's not a good idea. 2 or 3 is usually the maximum. You start getting more than that, and sometimes you can create more problems for yourself unless you are really familiar with how to manage VLANs. Okay, so when to use them? To increase security, a lot of times people want a guest network, which allows the guest to be on the internet, but not on the main network that is running the rest of the business or the home or whatever the case is that is in your installation. And that, like I said, separates or isolates that network traffic. It lets the guest only have access to the internet and not anything else. Whereas the main network, of course, does have access to everything else and the internet. So it's a way to keep things separated if you need to. You can also control the amount of data on a particular subnet. For example, things like camera CCTV systems. And then in the United States, we have laws that if you're going to use what we call a point of sale system or a credit card machine where you're going to take payment, that has to be separated from the main and regular network. And so VLANs are a way to do that as well. A specific application is, if any of you have used a product called Just Add Power, which is a video over IP system, they also use VLANs instead of multicasting for their product, which has a couple of unique advantages. So that's a unique, a very specific application of when VLANs are used. And I mention that only because we've worked with them for a very long time, and they use, like I said, they use VLANs for their entire product line. So let's talk about how VLANs work. And this is an overview. This is certainly not everything to do with VLANs, but if you can understand these two concepts, you will be very far down the road of being able to understand what a VLAN is doing and why it's appropriate to use. The first one is called a trunk. And a trunk is a word that means I'm sending more than one network down one Ethernet cable. So in other words, I have one cable, but I'm sending multiple networks down that cable. So I may have, for example, 192.168.0, 192.168.1, and 192.168.3. And all three of those can travel down the same single Ethernet cable out of one port. But you need to know how to separate them out. And that's where tagging comes in. When you do that, when you do trunking and you're sending multiple networks down the same cable, a tag is an identifier that is added to that data that says, I belong to number 1 or number 2 or number 3 or however many VLANs you happen to have. And so instead of just your standard data packet here, which has all of these things in it, preamble, destination, source, data, all those things, it actually adds a VLAN tag that says I belong to this network, so that when it travels from one switch to another switch or router to switch or whatever the case is, it knows what VLAN that data belongs to and can keep them all straight and separate. Okay, so we have trunking and we have tagging. Trunking and tagging usually only happen between your network infrastructure equipment. So things like routers, managed switches, access points, the type of things that make your network run. They do not happen between your end devices. So you're not going to have VLAN trunking and tagging on your laptop or your Vadio camera or your mobile phone or anything like that. Those are not affected by VLAN tagging and trunking. It's only within the network infrastructure equipment. There are some things because of the walls that VLANs build that they will not allow. And one of those things is regular broadcasts. For example, if you have an iPhone and you have an Apple TV on your network that is on a different VLAN, your iPhone will never see that Apple TV and will never light up the AirPlay icon to be able to mirror your phone to that Apple TV. Because broadcast messages do not go through those walls that the VLANs create. So you need to be aware of that. In other words, you don't want to put your automation system on a different VLAN from all of your, the rest of your audio video equipment, for example, because you'll never see most of that equipment because there's a wall separating those two networks. But if you remember, I said there was a door that you can open to allow certain types of traffic to go through. VLANs will allow direct IP routing. So for example, if you have a CCTV system that is on a different VLAN from the main VLAN, that's okay. If your automation system needs to go get a camera image from one of the cameras on that different VLAN, you can have the automation system get that image because you're telling it the direct IP address to go get that image from. So broadcasts don't work across VLANs, but if you have a device that needs to get information from a specific IP address that's on a different VLAN, that is the door that you open that can go get that information and bring it back to the main network. Okay, I hope that makes sense. Any questions so far on VLANs and what we've covered?
Hi, Jared. There is another question, but not directly related to VLAN. One of our guests asked, could you give us the best configuration file for Dante, QoS, IGMP, and etc.? It's about the configuration file.
Okay. Yes, I can tell you where to go. I will show you here in just a few minutes on the website where you can go get that information. We do have setup guides that go step by step on the switch of how to set up Dante and QoS. So yes, I will show you that in just a moment.
Thank you. So no more questions, please go ahead.
Okay, I'll continue on then. Okay, so with VLANs, they also have a pretty easy setup. We've talked about a lot of different terms and a lot of things that VLANs will and will not do. But when it comes down to the configuration, all of your VLAN configuration is on one screen, which is really great. And it's this VLAN configuration screen here. Now, again, there's lots of different scenarios and things that you can and may need to do. So I'm not going to go through detail today. Again, I just don't have time to do that. But we do have several videos that are on our university that tell you step by step how to set up VLANs. And we also have a full hour-long webinar that goes over VLANs in much more detail that does explain how to set these things up. The other option for you is if you need a little extra help, we do have both a phone call and a chat for our support team, and they will be happy to help walk you through and help you set up VLANs for what you need it to be. So lots of options for you to be able to know how to do this. But it is pretty much all on one screen. That's very nice. Okay? And that's all I had for VLANs so far. Let's talk about multicasting a little bit, because this is what the majority of people use for video over IP. And there's a lot of definitions, a lot of words that people use that sometimes we don't understand exactly what that means. And so I'd like to try and go through some of these things so that when you click on, when the setup guide says click on fast leave, you will now know what fast leave means if you don't already. Okay, so the first definition is called an IGMP join. Now, to define this, IGMP means Internet Group Management Protocol. And by definition, what it's doing is managing a group of devices for who gets what data stream. That's essentially what it does. So a join basically means someone in the group, in our industry, this generally is something like a video over IP transmitter or receiver that raises its hand and says, I want to be part of this group that you're going to manage. And I want to be part of a particular multicast stream that you have available that you just told me is available. I would like to be part of that. That's what join means. Leave means, can I leave that multicast stream? Now, there is a difference between leave and fast leave. When a regular leave happens, which means, let's say it's a video over IP receiver from maybe from Vadio, maybe from Crestron NVX, something like that. And this NVX receiver says, I want to leave the multicast stream. With a regular leave, the switch will start to ask more questions. It will say, okay, are you sure you want to leave? Are you really sure you want to leave? Does anyone else want to leave? And it will start asking all of these additional questions. What that means is that when you switch from one source to another, it does not happen quickly, because the switch is asking this receiver and all the other receivers if they're sure they want to leave or what everybody wants to do. And it slows things down, and it makes your switching from one source to another happen in 5 to 6 to 7 seconds or more. And certainly that's not what we're trying to accomplish for any of our customers. So there is another option that you can choose called fast leave. And what fast leave means is all of those questions that the switch asks go away. They are not asked anymore. And so when the receiver, the NVX receiver says, I want to leave this stream, the switch says, okay, see you later. And it does not ask that receiver or any other questions. And so it makes your switching much faster. And now you can switch sources within usually a second or less because all of those questions go away. So that's the difference between leave and fast leave. Again, I understand this is an overview. I'm very much generalizing all of this, but I'm trying to make it easy to understand and explain. I hope you understand what I'm saying. Okay, so we've talked about this. It's a protocol that manages multicast groups. It's similar in idea to this. If you imagine that we are all little kids again, and we're all in school, and we're at the playground, and we all want to play a sport. Now, I don't know how your school was, but at my school, we generally chose someone to pick the teams that we were going to be on. And that's kind of what IGMP does. It says who wants to be on my team or who wants to be part of this group. And all of the other people, whether not people in this case, all of the devices say I do. And it's going to be devices like your Dante devices and your video over IP or any other audio over IP device. They're going to say, yes, we want to be part of the group. But all the other devices on your network, like yourself or your mobile phones or your CCTV cameras or your iPads, or your laptops, they don't say anything about wanting to be part of a group. They just want regular data on the network. And so it works really well to be able to do that. And that's what IGMP does. There's another term called a querier, which basically is someone who asks questions. In this case, it's the switch asking a question to each network device. Remember, we're talking about who's going to pick teams on the playground. Well, the switch is the one that picks the teams. It's kind of like if you've ever seen an auction where people are bidding on items. The querier is the person asking the question of who wants to be part of the group. In this case, as you can see in the picture, it's the person behind the stand or the podium that is asking who wants to be part of the group. There's another term called IGMP snooping, and this one is a little bit of a strange term. But really what this means is this is the person at that same auction that is listening to the questions and calling out the responses. So it's listening to the devices saying, yes, I want to be part of the group, or other devices saying, no, we don't really care about that group. We don't want to be part of it. And it will then reply back to the switch and says, hey, I know which devices want to be part of the group. Let's form the group out of these devices that said they want to be part of it. Does that make sense to everyone? You have someone asking the question and then another part of the switch that's listening for the answer. Does that make sense? If not, let me know. Okay, and this is how multicast works. On the left-hand side, I have two sources. Doesn't matter what they are. Could be a camera, could be, a TV device. Doesn't matter what it is. There's two sources. They both send a stream to the Ethernet switch. On the right side of the screen, you can see I have 4 TVs or 4 displays. What IGMP does is it sends out a request saying who wants to join. Now let's say I've got a video over IP receiver connected to every one of these TVs. These receivers are going to reply back and say, we want to be part of the group and we want to join the multicast streams. And so the switch then sends out kind of like a program guide on your TV that says, okay, these are the streams from the sources that are available to you. And it can be 2 sources, it can be 20 sources, it just depends on how many transmitters you have in the system. And so the TVs say, or the receivers say, all right, fine, I want to then join. Let's say receiver number 3 wants to join. And the switch will say, okay, fine, I will send you that particular stream from source number 1. If you want to join another TV to that source, the great thing about multicast is instead of the original source having to send 2 streams, that second TV just simply joins the same stream that's already going on. That's why it's called multicast, because it can send one stream to multiple devices. Now let's say that the TV number 1 wants to leave the stream, but TV number 4 wants to join the second stream. It can do that without a problem, and then the switch handles all of this, which is why the Ethernet switch becomes your video switching matrix, because it handles all of this and just sends different data to different devices as they request to join or leave. Now, we've talked a lot of different definitions and a lot of things about multicasting. However, just like the other technologies, when it comes to configuring it on a switch, it really is not very difficult. A few brands that we work with are, as you can see on the screen here, there's a lot of them. What I want you to remember from this screen is that we are compatible with just about every brand of video over IP product that is on the market, because they pretty much all use the same multicasting definitions that we just went through, which are standard network protocols on every switch. So we will work with just about everyone. As far as the setup, there are with some of the other products, only 2 screens that you need to know of to set up everything that we just talked about. So it really isn't that difficult. There is, under IGMP snooping, there's a screen called Basic Configuration and one called VLAN Configuration. Now, VLAN configuration sometimes can be confusing because you aren't necessarily setting up a new VLAN for this. All it means is that you're telling the switch which VLAN you want the IGMP to run on, or what you want the multicast to run on. And there's always at least one VLAN. There's always one network that you're dealing with. And so all you have to do is go in and say, yes, I want it to run on the already existing VLAN that's running through the switch. And so it's pretty simple. Again, there's detailed instructions of how to do all of this. But I want to make it clear that all of these setup things, even though they are very heavy on technology, there's a lot to them, and there's a lot of things to know about them. When it comes time to set them up, we've tried very hard to make it very easy for you to set up inside the interface. As you can see with our switches, there is no command line. You do not have to know any code. Everything is done in the user interface that shows up on your screen. Okay, any questions about multicasting or anything else that has come up?
Hi, guests. So you have any questions, you may just unmute to ask or leave your question in the chat box. Any questions? So so far no more.
Yes.
Yeah, please go ahead. Yeah.
All right. If questions come in, we'll be happy to answer them at the end. Okay. Along with the configuration, here is where we have all of the documents on our website. If you go to legrandav.com and click and just highlight over the word tools, this whole menu system will show up. You want to click right here where it says networking tools. When you click on that, in fact, I'll show you real quickly here. Oops, sorry about that. When you click on that, you go to tools and click on networking tools right here. Oh, why is it not sharing? There we go. When you click on tools, you can see all of the different configuration guides here. Here's for Crestron NVX, Dante, and several others. They're all about the same, but that is step-by-step instructions of how to do all of these things.
Hi, Jared. We have two more questions now.
Okay.
One is, can the switch use IGMP Wi-Fi and PIM SSM for specific multicast?
The switches do not do PIM. What was the other part of the question? I'm sorry.
Can the switch use IGMP Wi-Fi and PIM SSM source specific multicast?
Okay. Yes, they do IGMP v3. Most of the products in our industry use v2, version 2. Most of the video over IP products use version 2, but yes, the switches are v3 version 3 capable. But we don't do PIM SSM. Actually, hold on a minute. Let me think about that. I might be wrong there. Let's see. Let me verify that. I don't think we do, but I want to be sure. So I don't think so. But yes, version 3 we do use. Let's see here. I see another question. May we know how to set up direct IP routing among VLANs? Yes, that's actually typically not done on the switch. That's generally done on a router because the router is the one that's routing between the two VLANs. And I don't have that in my slide deck today, but I'd be more than happy to direct you to some materials that show you how to do that. It's called, I just forgot the name. It's called inter-VLAN routing on a router. And yes, we are capable of doing it. All right, let me go back to my presentation here. Okay. The last thing I wanted to talk about before I turn it back over, I was asked to talk about ProWatch a little bit, which is our remote management software. ProWatch, in order to work with switches, our main piece of software is built into our routers. And the switches we call ProWatch integrated, meaning their interface is integrated into ProWatch for things like power cycling PoE outlets, seeing what devices are plugged into each port, being able to control PoE. All of that is built into ProWatch as long as you have a router that has ProWatch on it on the network. Unfortunately, at this time, we don't have the ability to just put a switch in and have it run ProWatch. So it does currently require a Luxul router to be able to have the ProWatch remote functionality in your system. So if you're putting routers in, fantastic. We'd love for you to take a look at a Luxul router and see if it will work for what you need. They're very robust routers. They work very, very well. And they do include ProWatch for free. But I wanted to just be clear about that since we spent so much time talking about switches that unfortunately, like I said, at this point, you do need to have a router in the system that's running ProWatch in order to get the switch integration into ProWatch. It's not available just by itself. But what ProWatch can do when you do have that router running is it will find all of the devices on your network. Does not matter what brand they are, all of them will be discovered. And then you can see on the right-hand side here, this is what a switch looks like inside the ProWatch interface. It will tell you how much PoE power you're using. Like I said, you can see here, you can power cycle individual ports with PoE. You can click on individual ports and get more information about how much data has passed through, what the device is that is plugged into that port. But all of this does require a router to be on the network. Unfortunately, switches just don't have enough extra memory to run ProWatch by themselves. So at this point, that's the way that it works. Are there any questions about ProWatch? I will say that it's a very powerful piece of software that can save you service calls from having to run all over your city. So instead of being having to go somewhere to perform a network change, a lot of that you can do right from your mobile phone or your tablet or your laptop. There's a web version as well that you can just log on to with a regular web browser. So it's very powerful, can be used really, really well with the right equipment in your system. And that is the majority of what I had for today. Again, I wanted to leave plenty of time for questions and for your giveaway. I do see a question here about if there's any routers that do not do ProWatch. There is only one that does not, and that's our entry-level wireless router, the XWR 1200, does not have ProWatch capabilities. But The other three routers, the XWR 3150 and both the ABR XBR 4500 and ABR 5000 do have ProWatch built in. And with that, I will turn it back to you.
Yeah. Hi all. Any more questions? Okay. So if currently, okay. Oh yeah, one more. Yeah.
Oh, he says he does lots of, of course, the one that doesn't have ProWatch in. We do have plans to have an external box that you can add to any network. With current chipset shortages and product delays in general, unfortunately, I'm probably not going to have that for at least another year or more. So yes, just like the Domos box. We do eventually want to have something like that, but right now it's not right around the corner. It's a ways down the road, to be perfectly honest with you. But eventually we would like to have something like that. Yes. So if you move to 3150s, Tim, then you're set.
Hello. So if there are no more questions, then that's we call the end of this webinar. So in case you have any questions in future, just feel free to contact me or Jared. So we are very happy to answer you. Yeah. So thank you, Jared, again. Yeah, thanks for all the guests to participate in this webinar. Yeah. So our APEC regional headquarters will regularly run webinar and communication EDM to update our newest technology and products. So stay tuned. Thank you. So bye bye.
Thank you, everyone. Bye bye.
Thank you.